In this video, I will show you how to solve quadratic inequalities such as this one. The key is to start by solving the related equation x squared minus x minus 2 equals 0. Because if you can determine the points where the function equals 0, it's easier to find where it's less than 0 or where it's greater than 0. So usually this is going to be factorable. So that would be the way to solve this related equation. We're going to find the zeros this way. So x squared can only be x times x. Looking at the 2, that would be 2 times 1. There are a lot of ways to factor, but I always think inner plus outer must equal the middle. Inner, I have 2x. Outer, I have 1x. That has to equal the middle, that is negative 1x. So if I had a negative 2 and a positive 1, that would make negative 1x. So that means negative 2 and positive 1. And negative 2 times 1 is negative 2. So there we have factored correctly. So continuing to solve this equation, we would set these two factors equal to 0. So x minus 2 equals 0, x plus 1 equals 0. This will give us the two zeros, x equals 2 and x equals negative 1. Now, let's plot those two zeros on a number line. These are the two numbers at which this function equals 0. Okay, so the function equals 0 at 2, and the function equals 0 at negative 1. Now the reason why I'm putting these as open circles is because we want to graph the places where the function is less than 0. So we do not want to include the values where the function is equal to 0, which is what these are. So we will show that these endpoints are not included by making them open circles. Now, we have created three sort of regions here. Values to the left of negative 1, values between negative 1 and 2, and values to the right of 2. Our strategy will be to pick a test value in each one of these intervals to find out where the function is less than 0, since that's what we want. Okay, so let's set up a chart to help us. Okay, so we have three intervals here. So let's pick a test value that is less than negative 1. So for example, we could investigate what is the value of the function at negative 2. Okay, and specifically we want to know, is it less than 0, like yes or no? We also want to pick a value between negative 1 and 2. So for example, we could investigate the value of the function at 0, because that's a value between negative 1 and 2. And again, we want to find out if that is less than 0, all right, because that would be a solution to this inequality. And then finally, we need to pick a value that's greater than 2, for example, 3. So let's test the value of the function at 3 and find out, is that less than 0? Okay, in every case we want to see, is it less than 0? Okay, we're going to use our calculator to help us. We should start by typing this function into the table feature of the calculator. So on this type of calculator, a TI-30XS multi-view, we would hit the table button like this. And so we have x squared minus x minus 2. So that would be x squared minus x minus 2. Enter. All right, now for this procedure, I prefer to use the Ask X feature. It just gives me direct control. So that's what I would recommend. All right, so we want to know about these specific three values. So I can just type them in, -2, 0, and 3. It's very easy. So I'll type in -2, and that I see the value of that. Type in 0, see the value there, and 3. Okay, so I'm getting 4, -2, and 4. Okay, so 4, -2, and 4. Now the question is this less than 0? Is 4 less than 0? No. So that tells me that's not a solution. Is -2 less than 0? Yes, yes it is. That tells me this is a solution. And of course we already spoke of 4 and how it is not less than 0. So this yes that we got, -2 is less than 0. That tells us that this is a solution. 0 is a solution. That means any point in this interval is going to be a solution. So I will show that by drawing the segment between -1 and 2, illustrating that all of these points are solutions. Now these two intervals where we our test values turned out not to be solutions, that means that none of the values in those intervals will be solutions. And we'll just show that by leaving that empty in our number line graph. So here we have graphed the solution set for this inequality, and that just leaves us to record the solution in interval notation up here. So in interval notation, our solutions run from -1 to 2. So I'm going to put -1, comma 2. And then we will use parentheses to indicate that -1 is not to be included as a solution, and 2 is not to be included. Parentheses mean do not include the endpoints. And that's it. That's the complete solution to problem number 1. Notice that this looks just like an ordered pair, like the point -1, comma 2 on the xy plane, but in this context it means the interval from -1 to 2. All right, now let's just keep going with our practice and roll right on into problem number 2. Okay. So again, our solution will be to start by solving the related equation, x squared minus 7x plus 10 equals 0. All right, to find the places where this function equals 0. So probably this is going to be factorable. So x squared can only be x times x. 10 is 2 times 5. It's also 1 times 10, but have an eye on this -7. Inner plus outer must equal middle. Inner, I have 2x. Outer, I have 5x. In order to get -7x, both of these would have to be negative. So that means both of these would have to be negative. And that works out because -2 times -5 is positive 10. So now we have factored this correctly. So we can finish solving this by setting these factors equal to 0. So x minus 2 equals 0, and x minus, x minus 5 equals 0. So that's going to give me x equals 2 and x equals 5. So those are my zeros. So I'm going to graph those zeros on my number line. Okay, so the function equals 0 at 2. So I'm going to go ahead and put a dot there. And the function equals 0 at 5. So I'm going to put a dot there. Now last time I graphed these points on the number line, I left them as open circles. This time I made them closed circles. The difference is, this time I'm looking for the places where the function is greater than or equal to 0. So these numbers represent places where the function equals 0. So we want to include those in the solution, and we'll show that by making these closed circles. So these are part of the solution. Okay, now, these endpoints have separated the number line into 3 zones. We have this interval to the left, this interval between the 2 zeros, and the interval that is to the right. So it is time to pick a test value in each one of these intervals to see whether or not the interval contains solutions to the inequality. So let's pick an interval, let's pick a test value that's to the left of 2. I like 0, so I'll pick 0 as a test value. And remember, for this function, the solutions need to be greater than or equal to 0. So we need to see, is the function greater than or equal to 0 at this point? Okay, now let's pick a value between 2 and 5. So we could pick 3 or 4. I'll just pick 3. So let's find the value of the function at 3 and see if that is greater than or equal to 0 like we want. And then finally, let's pick a test value that is to the right of 5, greater than 5. So of course we'll just pick 6. Okay, and we want to see, is the function greater than or equal to 0 there, because that would make it a solution. And again, we will use our calculator to help us. So we should just type in the equation. All right, this side of the equation, x squared minus 7x plus 10. So we have x squared minus 7x plus 10. Enter. And again, I recommend using Ask X mode because it just works out ever so conveniently for this process. So we want to test these 3 specific values, 0, 3, and 6. So we can just type those in directly, 0, 3, and 6. It works out great. So we got 10, negative 2, and 4. Okay, so I got 10, negative 2, and 4. And the question is, in each case, are these greater than or equal to 0? Well, is 10 greater than or equal to 0? Well, yes it is. So that means 0 is a solution. So if 0 is a solution, that means every point in this interval is a solution. And I'm going to show that by drawing this ray over here. All right, all of these points are solutions. Is negative 2 greater than or equal to 0? No, negative 2 is not greater than or equal to 0. Wait, yeah, negative 2 is not greater than or equal. That means 3 is not a solution. So that means none of the points in this interval will be solutions. Okay, so we will show that by just leaving this empty. Is 4 greater than or equal to 0? Yes it is. That means 6 is a solution, which means that every point in this interval is a solution. So we will show that by drawing a ray in that interval. Okay, so everywhere that we have drawn blue, everywhere you see blue up here, is a solution. So now we have to record this solution that we have graphed in interval notation on this line here. Okay, so this is in 2 parts, so my solution will be written in 2 parts. So this ray over here to the left is from negative infinity to 2. So that's my first interval, will be negative infinity to 2. Now 2 is to be included as a solution, as you can tell, because we made it an a closed circle. So I'm going to show that with a bracket, that 2 is part of the solution. And then this interval to the right goes from 5 to infinity. So I'm going to put 5 to infinity, positive infinity. Again, I'll put a bracket on the 5 to show that 5 is included. That's what the closed circle means as well. Infinity always gets a parenthesis. Now, whenever your solution is in two parts like this, you're going to connect them with a union symbol, all right, a big old U, okay, to join them as together as one. So this is the solution to problem number 2. All right, I'm going to go ahead and do one more problem on this video, and then I'll put the other 3 problems on another video. So just like before, our strategy will be to solve the related equation, x squared minus 8x plus 7 equals 0. All right, we're going to find the zeros of this function. And probably this is going to turn out to be factorable. X squared can only factor as x times x. 7 can only factor as 1 times 7. Inner plus outer must equal middle. Inner, I have 1x. Outer, I have 7x. To get a middle of negative 8, both of these would have to be negative, which works out great because negative 1 times negative 7 is positive 7. So we have now factored correctly. To find the zeros, the solutions to this equation, I would set each of these factors equal to 0. All right, so that gives me x equals 1 and x equals 7. So these are the 2 values at which the function equals 0. All right, so the function equals 0 at 1. So I'm going to put a closed circle there. The function equals 0 at 7. So I'm going to put a closed circle there. Again, I'm using a closed circle instead of an open circle because the solutions to this inequality will be the values where the function is less than or equal to 0. These are places where the function equals 0, so they are to be included as a solution. So we show that with a closed circle. As opposed to if this was just less than 0, we would not want to include these places where the function is equal to 0, and we would then make them open circles. Okay? So if you need a shortcut for that, then you're going to sit there and think, well, if it says or equal to, we're going to make them closed circles. If it doesn't say or equal to, we'll make them open circles. Anyway, now we've created 3 intervals, 3 zones on this number line. We have this first zone that's to the left of 1. We have a zone between 1 and 7. And we have this interval that is greater than 7. So we're going to pick a test value in each interval and find out if it's a solution to this inequality or not. So here we go. We're going to pick a test value in each interval. Okay, so in the first interval, 0 would be a good value to use. I mean, you could use any of these numbers, but 0 works out great. And again, for this problem, we want to know, is it less than or equal to 0? Because that's what it takes to be a solution for this problem. Now, in the middle interval, we could pick any of these numbers. I'm just going to pick 2. All right, so let's check that out. And let's see if the function is less than or equal to 0 there. And to the right, in this interval, I'm going to pick 8. So let's test out the value of the function at 8 and see is that less than or equal to 0. Once again, I'm going to use my TI-30XS multiview to make this process quicker. So we should go ahead and type in this part of the problem, x squared minus 8x plus 7. So x squared minus 8x plus 7. Enter. Make sure your calculator is in Ask X mode, because that is the most efficient thing to do. This works out great because we want to check the value of the function at these 3 specific points, 0, 2, and 8. And we can just type them in, 0, 2, and 8. You just go straight to them. So I'm seeing 7, -5, and 7. Okay, in each case we are asking ourselves, is it less than or equal to 0? Is 7 less than or equal to 0? No, it is not less than or equal to 0. So that means 0 is not a solution, so none of these points are solutions, so we'll leave it blank. Is 5 less than or equal to 0? Yes, it is less than or equal to 0. That means 2 is a solution, which means that all of these points in this interval are solutions. And we will show that by drawing a segment right here. And we already answered this question. No, 7 is not less than or equal to 0. So that means 8 is not a solution. So that means none of these points in this interval will be solutions. So we will show that by leaving that blank. So here we have graphed the solution set, and we can now translate that into interval notation. The solutions are the points from 1 to 7. So 1 to 7, including 1 and 7 themselves. So we will show that those values are included by using brackets. Okay, and that's it. That's the end of problem number 3. And that's going to do it for this video. I will do a few more problems on the next video. I'll see you there.